Our, this line right here would represent 0 or 360. I don't care which one you use, but it has to be one of the two. Okay, let's do the obvious ones. This would be
90, 180, 270.
Okay, so those are the multiples of 90. Then, what did the other angles represent? Right, the same ones on our hand trick. So we have 0, 30 degrees, 45 degrees, 60 degrees. And then we use reference angles. This is a 30-degree angle. Reference angles come from the x-axis. So this one is also a 30-degree angle. So what do we do? Okay, here is my 45. This is our 60. Okay, everybody knows how we got those. Well, that pattern continues. So this next line is also a 30-degree reference angle. This one is also a 45 degree. This one is a 60 degree. So in the third quadrant, we add our reference angles. So 180 plus 30.
210.
180 plus 45.
225.
180 plus 60.
240.
Okay, then we came down here. So this would be my 30 degree. So we did 360 minus 30.
30.
And our 45, we do 360 minus 45.
315.
And then 360 minus 60. So you notice as you go around the circle, these angles are continually getting larger. If you accidentally flip two of them, that pattern won't hold. So you'll catch your mistake that way. All right, then when we added in our radians, we had different ways of converting. We know that 180 degrees is equal to pi radians. So this is 1 pi. So this would be 0 radians or 2 pi. Okay, we get it by taking our degree and we multiply by pi over 180. So 90 times pi over 180 is 270 times pi over 180. So this is like 0 pi over 2, 1 pi over 2. 2 pi over 2 is pi. 3 pi over 2, 4 pi over 2 is 2 pi. But then we see a lot of other patterns. All of these that had a reference angle of 60 had what in the denominator? Or sorry, a reference angle of 30 had what in the denominator? 6. Right? And they were all had a pi on top. So we know that much. The only thing that changed was the numerator. So here 30 degrees was pi over 6. And here it's a little less than pi. So what was the numerator? 5 pi over 6 because it was smaller than pi. Here we added, so it would be 7 pi over 6. And here it's like taking 2 pi minus pi over 6 and we got 11. So everything with a reference angle of 30 has 6 on the denominator. Everything with a reference angle of 45 ended up with what on the denominator?
4.
And yesterday we worked these out by, evaluating each one, either multiplying by pi over 180 or by subtracting or adding from our reference angle. But today I'm focusing on the patterns. So if I look at this one in the second quadrant, we did like pi minus our reference angle. So this would be 3 pi over 4. This would be 5 pi over 4, and this one was 7 pi over 4. Okay, everything with a reference angle of 60 ended up with what in the denominator? Okay, so in the first quadrant, it's just pi over 3. In the second, it was,
2,
in the third,
4,
and in the fourth. So we can look at patterns here. Everything in the second quadrant, what's the pattern for all of these?
1 less.
Yeah. You know what the denominator has to be. And the numerator is just 1 less. So the top is 1 less than the bottom. Okay. If we look in the third quadrant, all of those, we had 7 over 6, 5 over 4, 4 over 3. What's the pattern?
1 more than the denominator.
Because it's bigger than pi. So that's why it turned out to be higher. Okay, in the fourth, what is it?
1 less 2 times.
Double minus 1. If you take the bottom times 2 and subtract 1 from it. Now, do we have to memorize these patterns? Absolutely not. We figured every one of these angles out yesterday without memorizing any patterns whatsoever. But these are some tricks that we can use to help us as we work through here. Any questions on that? So let's look at some problems. We're going to do the same thing that we've been doing in degrees, except we'll look at it in radians. Right. So if I ask you to find the sine of pi over 6. No, exact values. So we just need to think. When I see pi over 6, what degree measure is that? What's the sine of 30 degrees?
That would be
1 half.
Okay, this was the back page of your test. The only difference is I said 30 degrees, but we're going to have radians as well, so we need to be comfortable working it in either form.
Why do we have the radians if we're just going to turn it back into a reference angle?
We don't have to turn it into degrees. That's just what we're thinking right now because we're more used to asking in degrees. As we get more comfortable with radians, we should get to the point where we don't have to think, oh, that is 30 degrees. We should just know it. But we'll get there. Okay, when I see 3 pi over 4, what quadrant is that in? It is very, very easy to tell quadrants when you're in radians. Because anything in the second quadrant, what's the pattern? The top is 1 less than the bottom. So I see that pattern. I know this is quadrant 2. My reference angle, when I look at that, the reference angle is just pi over the denominator. So pi over 4, which we should recognize is 45 degrees. Remember, if I ever gave you one that you didn't know, how do we convert pi over 4 into degrees if we wanted to?
Times 180 over pi.
We did that yesterday because pi radians is equal to 180 degrees. And the pi's would cancel, and 180 divided by 4 is 45. So that's how we worked it out yesterday. In quadrant 2, is cosine positive or negative? Negative. And what is the cosine of 45 degrees?
Square root of 2 over 2.
Next. 5 pi over 3. So in quadrant 1, it's just pi over something. In quadrant 2, the top is 1 less. In quadrant 3, the top is
Double minus 1.
Yeah. In quadrant 3, the top is 1 more, but this is double minus 1, so that's quadrant 4. Reference angle is just like if you ignore that number on top. It's just pi over 3, which is 60 degrees. Okay, what is the tangent of 60 degrees?
It's gotta be negative.
Radical 3 over radical 1, which is radical 3, but because we are in quadrant 4, it would be negative radical 3. Okay, so exact same thing that we've been doing. The only difference is the original problem had a radian measure instead of a degree measure. But that doesn't change anything. Any questions there? So, I want you guys to practice. 30 through 62, what does EOE mean?
Even or odd even.
Every other even. So
Oh,
it's like you do
thank you.
30, you skip 32, you do 34.
Me and Grant were on the same page. We're just doing every problem, is what that means.
Yeah.
That would be kind of rude.
No, but it would make you feel like you weren't doing as many.
Yeah, you
When
do
you
the
read
even, and you do the next odd. And
Do an even? Yeah, I know what you mean.
68 through 86 are evens only.